Hello dear students, today we will study about the numerical problems asked in National Education Board NEB of Nepal from thermal expansion. At first let us take the helping tips. Linear expansivity alpha is the ratio of change in length. Linear expansivity alpha is defined as the change in length per unit change in temperature. Similarly, superficial expansivity beta is change in area per unit change in temperature, and cubical expansivity is change in volume per unit change in volume. The units of alpha, beta and gamma are per degree Celsius or per Kelvin. From these relations, we can find L2 is equal to L1, 1 plus alpha delta theta. Similarly, A2 is equal to A1, 1 plus beta delta theta, and V2 is equal to V1, 1 plus gamma delta theta. Ratio of alpha is to beta is to gamma is 1 is to 2 is to 3. If ρ1 is the density at temperature theta 1 and ρ2 is density at temperature theta 2, then ρ2 is equal to ρ1 upon 1 plus gamma delta theta, or coefficient of real expansion is equal to the sum of coefficient of apparent expansion plus coefficient of cubical expansion of vessel, which is equal to 3 into linear expansivity of vessel. Loss or gain of time by a clock pendulum is given by 1 by 2 alpha delta theta into t, where t is the given time duration. When theta 2 is greater than theta 1, then clock will lose time, and when theta 2 is less than theta 1, then the clock will gain time. First question is, at what temperature wood will just sink in benzene liquid if their densities at 0 degree Celsius are 8.8 into 10 to power 2 kg per meter cube and 9 into 10 to power 2 kg per meter cube respectively. Cubical expansivity of wood is gamma W is equal to 1.5 into 10 to minus 4 per Kelvin, and cubical expansivity of benzene is gamma B is equal to 1.2 into 10 to minus 3 per Kelvin. Now, solution to question first. Given at temperature theta 1 is equal to 0 degree Celsius, ρ1 means density of wood is 8.8 into 10 to power 2 kg per meter cube, and density of benzene is 9 into 10 to power 2 kg per meter cube. Cubical expansivity of wood is 1.5 into 10 to minus 4 per Kelvin, and cubical expansivity of benzene is 1.2 into 10 to minus 3 per Kelvin. We have to find the temperature. Theta 2. At which wood will just sink in benzene. Solution: wood will just sink in benzene when their densities become equal. Wood will just sink or just float in benzene at temperature theta 2 if their densities are equal. That is, thus rho 2 of wood must be equal to rho 2 of benzene, which means that rho 1 of wood upon 1 plus gamma of wood delta theta is equal to rho 1 of benzene upon 1 plus gamma of benzene delta theta. Now values are known, therefore we get 8.8 into 10 to power 2 upon 1 plus 1.5 into 10 to minus 4 into delta theta. Theta minus 0 means theta will be equal to 9 into 10 to power 9 upon 1 plus 1.2 into 10 to minus 3. Theta minus 0 means theta. On solving, it gives theta as 21.97 degree Celsius, which is nearly 22 degree Celsius. Next question number 2. A glass flask of volume 400 cm cube is just filled with mercury at 0 degree Celsius. How much mercury will overflow when the temperature of system rises to 80 degree Celsius? Linear expansivity of glass is 1.8 into 10 to minus 6 per Kelvin and cubical expansivity of mercury is 1.8 into 10 to minus 4 per Kelvin. Now solution to question 2 given. V1 is equal to 400 cm cube. Initial volume of flask and mercury at temperature theta 1 is equal to 0 degree Celsius. At temperature theta 2 is equal to 80 degree Celsius, delta V apparent will be how much? Means volume of mercury that will overflow. Alpha of glass is given to be 1.8 into 10 to minus 6 per Kelvin, and gamma of mercury, which is real expansivity of mercury, is equal to 1.8 into 10 to minus 4 per Kelvin. Now solution. We know gamma is equal to cubical expansivity, gamma is equal to change in volume per unit volume per unit change in temperature. Therefore, delta V will be equal to gamma V1 delta theta. Hence, apparent volume delta V A, apparent volume delta V A will be equal to gamma apparent V1 delta theta, because gamma real is equal to gamma apparent plus gamma Bessel. This will be gamma apparent plus 3 alpha Bessel, and Bessel is that of glass, 3 alpha glass. Therefore, delta V apparent will be equal to gamma apparent can be written as gamma real minus 3 alpha glass into V1 into delta theta. Now values are known. Gamma real is 1.8 10 to minus 4. Minus 3 alpha glass is 1.8 into 10 to minus 6, and to V1 is 400, and delta theta is 80 minus 0. On simplification, it gives 5.59 cm cube. Therefore, 5.59 cm cube mercury will overflow at 80 degree Celsius. Now question number 3. Steel wire of length 8 meter and diameter 4 millimeter is fixed between two rigid supports. Find the increase in tension when temperature falls by 10 degree Celsius. Young's modulus Y and linear expansivity alpha for steel are given. Solution to question 3. Given this is steel wire, fixed between two rigid supports. Initial length is 8 meter, diameter is 4 millimeter, therefore radius is 2 millimeter, 0.002 meter. Young's modulus and linear expansivity are given. Young's modulus is 2 into 10 to the power 11 Newton per meter square and linear expansivity 1.2 into 10 to minus 5 per Kelvin. We have to find the tension force. Tension when temperature falls by 10 degree Celsius. Tension or force when thermal expansion is resisted is given by F is equal to YA alpha delta theta. This will be YA means pi r square alpha delta theta. Values are known 2 into 10 to power 11 into pi into 0.002 square into 1.2 into 10 to minus 5 into 10 delta theta means 10. On simplification it gives 301.56 Newton, which is nearly 301.6 Newton. Question number 4. An iron rod of length 100 meter at 10 degrees Celsius is used to measure a distance of 2 km on a day when temperature is 40 degrees Celsius. Calculate the error in measuring distance. Alpha is 1.2 into 10 to minus 5 per Kelvin. Given for iron rod, L1 is equal to 100 meter at theta 1 is equal to 10 degrees Celsius. Linear expansivity alpha is equal to 1.2 into 10 to minus 5 per Kelvin. At temperature theta 2 is equal to 40 degrees Celsius. Error in the measurement of distance 2000 meter by the rod is what? Solution to question 4. Alpha is equal to delta L upon L1 upon delta theta. Therefore, delta L will be equal to alpha L1 delta theta. Alpha is 1.2 into 10 to minus 5. L1 is 100. Delta theta is 40 minus 10, which gives 0.036 meter. Therefore, total error in measuring distance 2000 meter will be equal to 2000 upon 100 into 0.036 is equal to 0.72 meter by unitary method. Next question number 5. A second pendulum made of brass keeps correct time at 10 degrees Celsius. How many seconds will it lose or gain at 35 degrees Celsius? Linear expansivity of brass is given. Solution to question 5. given for second pendulum made of brass. Alpha is 2 into 10 to power 5 per Kelvin linear expansivity. At temperature theta 1 is equal to 10 degrees Celsius. Clock is correct. At temperature theta 2 is equal to 35 degrees Celsius. Loss or gain of time per day is to be calculated. Solution: because theta 2 is greater than theta 1, therefore clock will lose time. Total loss of time in one day will be equal to 1 by 2 alpha delta theta into t. 1 by 2 into 2 into 10 to minus 5 into delta theta 35 minus 10 into t in one day is 86,400, which gives 21.6 seconds. Next question number 6. The marking on aluminum ruler and brass ruler are aligned at 0 degree Celsius. How far apart the 20 cm mark be on the two rulers at 40 degrees Celsius if the alignment of the left end is maintained? Linear expansivity of aluminum and brass are given. Solution to question 6 here given. At temperature theta 1 is equal to 10 degrees Celsius. At temperature theta 1 is equal to 0 degrees Celsius. Both scales are aligned, means difference between their lengths is 0. At temperature theta 2 is equal to 40 degrees Celsius. D2 will be what? If L1 brass is equal to L1 aluminum is equal to 20 cm. Initially at temperature theta 1, initial lengths of both rods are 20 cm. Then D2 will be what? At temperature theta 2. Alpha of aluminum and alpha of brass are given. Alpha of brass is 2 into 10 to minus 5 per Kelvin and alpha of aluminum is 2.4 into 10 to minus 5 per Kelvin. For differential expansion, d2 is equal to d1 plus L1 aluminum alpha aluminum minus L1 brass into alpha brass into theta 2 minus theta 1. d1 is 0 plus L1 aluminum 20 into alpha aluminum is 2.4 into 10 to minus 5 minus L1 aluminum is L1 brass is 20 into alpha brass is 2 into 10 to minus 5. Temperature difference is 40 minus 0 means 40. So we get D2 as 0.008 centimeter. Next question number 7. A brass pendulum keeps correct time at 15 degrees Celsius. How many seconds will it lose or gain per day at 0 degrees Celsius? Linear expansivity alpha is given. Solution. Question 7 given. For clock pendulum, made of brass. In this case, alpha is 2 into 10 to minus 5 per Kelvin for clock pendulum made of brass. Theta 1 is at theta 1 is equal to 15 degrees Celsius. Clock gives correct time. Then at theta 2 is equal to 20 degrees Celsius. Loss or gain of time per day is to be found. Because theta 2 is greater than theta 1, therefore clock will gain time. Total gain in time will be total gain in time per day will be equal to 1 by 2 into alpha delta theta into 1 day. 1 day is equivalent to 86,400 second. Therefore, it gives 1 by 2 into alpha into delta theta into this much, which gives 4.32 second. Next question number 9. Density of silver at 0 degree Celsius is 10,310 kg per meter cube and its linear expansivity is 0.000019 per Kelvin. Find its density at 100 degrees Celsius. So, solution to question 9. Given for silver metal, rho 1 is equal to 10,310 kg per meter cube at theta 1 is equal to 0 degree Celsius. Then rho 2 will be how much? At theta 2 is equal to 100 degree Celsius. Alpha is given to be 0.00000 19 per Kelvin. Therefore, gamma will be equal to 3 alpha is equal to 0.000057 per Kelvin. We know rho 2 is equal to rho 1 upon 1 plus gamma theta 2 minus theta 1. Therefore, it will be 10,310 upon 1 plus 0.000057 into 100 minus 0, which gives 10,251.57 kg per meter cube. Next question number 10. The question is, the length of an iron rod is measured with the brass scale. When both are at 10 degrees Celsius, the measured length is 50 cm. What is the length of rod at 40 cm? Solution to question 10 given. Length of iron rod is measured length of iron rod as measured with brass scale is 50 cm at theta 1 is equal to 10 degree Celsius. Then length of iron rod measured with brass scale will be how much? Alpha of brass and alpha of iron are given as alpha of iron is 16 into 10 to minus 6 per Kelvin and alpha of brass is 24 into 10 to minus 6 per Kelvin. Solution. L2 of iron will be equal to L1 of iron 1 plus alpha of iron into theta 2 minus theta 1. L1 of iron is 50. 1 plus alpha of iron is 16 into 10 to minus 6 into 40 at theta 2 is equal to 40 degrees Celsius. 40 minus 10, it gives 50.024 cm. Now, length of 1 cm brass scale at 40 degrees Celsius will be equal to 1 cm into 1 plus alpha of brass 40 minus or theta 2 minus theta 1 1 cm into 1 plus 24 into 10 to minus 6 into 40 minus 10, which gives 1.024 0.072 cm. Therefore, length of iron rod measured with brass scale at 40 degree Celsius will be equal to 50.024 divided by 1.00072, that is 49.988 cm. Next, question number 11. Question is, a brass rod of length 0.5 meter and a steel rod of length 0.6 meter, both at 0 degree Celsius, are heated to 75 degree Celsius. If the increase in length is same for both rods, find linear expansivity of brass. Linear expansivity of steel is given to be 12 into 10 to minus 6 per Kelvin. Solution to question 11 given. Alpha of steel 12 into 10 to minus 6 per Kelvin. We have to find alpha of brass, linear expansivity of brass. At temperature at theta 1 is equal to 0 degree Celsius, L1 of brass is given to be 0.4 meter, L1 of steel 0.6 meter. At theta 2 is equal to 75 degree Celsius. Change in length is same, that is delta L of brass is equal to delta L of steel. So, according to question, at temperature theta 2, change in length is same for both rods. So, delta L of brass is equal to delta L of steel, that is alpha brass L1 brass delta theta is equal to alpha steel L1 steel delta theta cancels out and we get alpha brass as alpha brass is equal to alpha steel L1 steel divided by L1 brass. Values are known 12 into 10 to minus 6 into L1 steel is 0.6 upon L1 brass is 0.4. So we get alpha brass as 18 into 10 to minus 6 per Kelvin. Next question number 12. An aluminum rod when measured with steel scale, both being at 25 degrees Celsius, appears to be 1 meter long. If the scale is correct at 0 degrees Celsius, what will be the length of rod at 0 degrees Celsius? Alpha of aluminum and alpha of steel are given. So, given solution to question number 12, given length of aluminum rod at 0 degrees Celsius means at theta 1 is equal to 0 degrees Celsius. According to question, L2 of aluminum as measured with the steel scale will be equal to L2 of steel is equal to L1 of steel 1 plus alpha of steel delta theta this will be equal to 1 meter into 1 plus alpha of steel is 12 into 10 to minus 6 into 25 minus 0, which gives 1.0003 meter. Or 100.03 centimeter. Now L2 aluminum will be equal to L1 aluminum 1 plus alpha aluminum theta 2 minus theta 1, which gives L1 aluminum as L2 aluminum divided by 1 plus alpha aluminum theta 2 minus theta 1, which is 1.000 or which gives 100.03 divided by 1 plus alpha aluminum is 26 into 10 to minus 6 into 25 minus 0, which gives 99.6 cm. Or 0.996 meter.